up, what up? I'm the math teacher Goat, and today in AP Precalculus, you are getting a full lesson in 2.2 change in linear and exponential functions. You can't spell exponential functions without fun. Make sure you like and subscribe. Go to the description, download the notes, follow along, yada, yada, yada. Leave a comment, blah, 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 blah. All right, getting right into it. We've got ourselves a warm-up. How many boxes are in figure 8? Figure 8, my favorite skating thing. Remember, you know what I'm talking about? We got 5 here. We got 9 there. You're going to be what? 6, you got 13 there. Oh, well, would you look at that? It's arithmetic. Where it seems like to me the first term is 5, the second term is 9, the third term is 13, and you're adding 4 every single time. So let's use the arithmetic sequence formula and do a little bit of mathy math. A sub n equals a sub 1 plus n minus 1, close parentheses, times the common difference. Okay? Keep in mind, some teachers might throw the common difference there. Hey man, it doesn't matter. You're my first term, you're my common difference, and you are going to be my n. So a sub 8 is going to equal 5 plus 8 minus 1 times 4, 5 plus PEMDAS 7 times 4, 5 plus PEMDAS 28, 5 plus 28 is Great Larry Bird jersey 33. Those of you who are fans of boy bands from the early 2000s with 3 members who...
Happy Friday, all teachers and staff. Just to let you know, there are some special treats in the cafeteria for you. It's our churro bar. Please help yourself. Make your way over to the cafeteria to partake in the special treats. Thank you.
And 5 plus 28 is the Great Larry Bird jersey 33. Those of you who are fans of boy bands from the early 2000s, 2 of which are dead, you'll appreciate that comment. Rest in peace to the members of LFO. There were only 3 of them. Only one of them survived. So what are we doing here? We are comparing the point-slope form of a linear function to the arithmetic sequence. So, you learned point-slope form as y minus y sub 1 equals m times the quantity x minus x sub 1. Well, now what we're doing is we're turning y into f of x. Let's add y sub 1 to both sides, and you're left with something that's basically the same thing as the arithmetic sequence. You see it? Now they're using the kth term instead of the first term. Hey man, no big deal. Same exact thing, right? Now a shifted exponential function would be something like, I don't know. I mean, I usually do exponential function as like a times b to the x. So I guess like maybe you would add or subtract something to x to make it look like k. I'm not sure exactly what the point is when I stole this from the internet, but they kind of look the same. They kind of look the same. Again, adding or subtracting would just move that left or right. Shifted. Now, over equal length input value intervals, which means if you have a chart and they all go up by the same x value every time, like that one does, over that, if the outputs of a function change, I guess we could say arithmetically, which means you just add and subtract every time, then the function is linear. You add the slope. Okay. Oh gosh, I really don't want to use multiplicatively because I don't know how to spell it. How do you spell multiplicatively?
Here's what I found.
Oh, all right, you ready? Multiplicatively. I could have guessed that. Basically, what this is saying is if you're adding or subtracting it from one number to the next for your y values, as long as the x values are consecutive, it's linear. If you're multiplying to get from one to the next, it's exponential. Okay, so this, again, it equates the linearness of a function to it being arithmetic, and it equates the geometricness to it being exponential. Okay, exponential functions. So There's no chart, but we do notice that the x's go up by 1. So what do you do to get from 1 to 4 to 16? Well, you times 4 every single time, of course. So could the function represent a linear function, exponential function, or neither? That's exponential. Five, 6, 7, so your equal length input value intervals. 3 goes to 7, 7 goes to 10. Looks like you add 4. Looks like you add 3. That's a big fat neither. Three, 5, 7, they go up by 2s every time, so that's perfectly legal. Negative 1 to 7 is 8. 7 to 15 is 8, so this is arithmetic. Arithmetic. Multiplicatively. That's a word that I can say 50 times and probably never screw it up. And I'm very proud of myself for doing that. Multiplicatively. Serendipitous. That's another fun word to say. Fun fact, exponential functions can have a domain of any number, but geometric sequences can have a domain of only integers. Wait a minute. Whoa, 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 whoa. If you're wondering why, well, like an exponential function, I could plug in like 1.5. Like an exponential function looks like this. Y equals a times b to the x. We kind of wrote that out. Whereas you have your geometric function, which is g sub n equals g sub 1 times r to the n minus 1. Wrong parentheses, wrong parentheses. Let me fix that. R to the n minus 1. Okay. Now, geometric says, what's the nth term of the sequence? What's the fifth term of the sequence? What's the eighth term of the sequence? The first term of the sequence? It's impossible to ask what's the 1.5th term of the sequence. Therefore, geometric deals with integers only, whereas exponential doesn't. You can plug in 1.5. If I say, like, I could plug in 0.5, like b to the 1/2 is the same thing as square root of b. It's not pretty, but it's going to be accurate. It's going to be doable. So you can do it. It is known that f of x is a linear function and passes through the points 3, 7, and 8, 1. Write an equation for its function. So let's do linear stuff. Let's not do arithmetic. Let's do point slope form the way that I want to. Well, maybe not the way that I want to. They want us to write it out as f of x. So if we use the equation that we wrote at the very beginning, f of x is going to equal y sub 1 plus m times the quantity x minus x sub 1. What I need first is I need my slope, which I don't have. I have 2 points. Well, how do I find the slope? I use the slope formula. So I'll call you x sub 1, y sub 1, x sub 2, y sub 2. And the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We called y sub 2 1. We called y sub 1 7, so 1 minus 7. We called x sub 2 8, and x sub 1 3. So this gives you negative 6 over positive 5, so negative 6 over 5. So that's my m, is negative 6 over 5. If I called you x sub 1, y sub 1, why don't I just stick with that? So my final answer for here is going to be f of x equals y sub 1, which I called 7, minus 6 over 5, x minus x sub 1, which I called 3. You could also answer this as f of x equals, instead of y sub 1, you could use y sub 2, so 1 minus 6 over 5 times quantity x minus 8. Both of those will be just fine. It is known that an exponential function, or that f of x is an exponential function, and that passes through the points 2, 5, and 4, 12, write in a linear equation for the function. So what I'm going to do is, instead of using the, I'm going to use the geometric form of the exponential function. So I'm going to use what they use, f of x, but I'm going to do g of k times the quantity r to the n minus k. Now this is going to be a pain in the butt. You see, this is exponential, which is the same as geometric. So you kind of have like a table here where it's supposed to be 2, 3, 4, and 2 is matched up with 5, and 4 is matched up with 12. But skadios. What's this? Basically, you have to figure out what you multiply to something twice, So you basically say 5 times what is going to be 12. So what you're going to do is you're going to write out 5 times what equals 12. Because it's exponential. So you're going to divide both sides by 5. X squared is going to equal 12 over 5. Square root both sides. Okay, normally you put a positive or negative there. I guess technically you still can. You still can. I mean, you can be positive or negative. But that x represents our r. So our r is going to be positive or negative the square root of 12 over 5. That's a mess. So what term do I have? I have a second term of 2. So you would be k. Okay, so k would be 2. And u would be g of k. So the equation is going to be f of x equals 5 times the quantity, positive or negative, square root of 12 over 5 to the n minus second power. Gross, awful, gross. Holy crap, is that bad? Well, let's move on from that. I really did not like that problem at all. Really did not like that problem at all. Let's get something a little bit friendlier, though. Are the tables linear, exponential, or neither? Let me see. You go up by 4. You go up by 4, so that's equal length input value intervals consecutively. What happens? Minus 4, minus 4, minus 4, minus 4, linear. 1 to 3 to 5 means you add 2 every time, so that's good. 2 to 6 to 18 looks like you're multiplying 3 every time, so that's exponential. Much friendlier than what we just did. Much friendlier. I'm the best. Mr. Butt has been collecting He-Man figures for 40 years. The number of figures he owns can be modeled by an arithmetic sequence, where the first year is year 1, period. The number of figures in year 5 was 12, and the number of figures in year 20 was 167. Okay. How many He-Man figures are there? All right, so we're looking at something that's arithmetic. All right, and we're going to use the arithmetic formula, but we're not going to use the a sub 1 version of the arithmetic formula. We're going to use the a sub k version. So we have a sub n is going to equal a sub k plus n minus k times common difference. Two things. We don't know the common difference. We know that in year 5 it was 12, and that in year 20 it was 167. So what we can do is we can take those 2 points, like pretend that they're in a table somewhere, like so. Okay, so 5 was 12, and then 20 was 167. And we'll just use the change of rate of change formula. So we'll call you A, we'll call you B, you'll be f of A, and you'll be f of B. So in order to find the common difference, we're going to use the average rate of change. So that's f of b, which is 167, minus f of a, which is 12, over b, which is 20, minus a, which is 5. 167 minus 12 is 155. 20 minus 5 is 15. And that ends up being 10 1/3. Something magical better happen, otherwise these numbers are awfully scary. Okay, well that's the common difference. That's the common difference. So we can let u then be if I make u k, then u would be my ak. Uh-oh. And then common difference, and then n is going to be 14. Okay, so a sub 14 is going to equal a sub k, which is 12, plus n, which is going to be 14, minus k, which is 5, times the common difference, which is 10 1/3. And I'll just write that out as, what is that, 31 over 3. So that's 12 plus 9. Oh, this will work out. 9 times 31 over 3. 9 times 31 over 3 is going to be, cross you out, make it 3. 93. 12 plus 93 is going to be 100. No way, 101, my favorite amount of Dalmatians. I should have made this about Dalmatians and not He-Man figures. And instead of Mr. Butt, I should have called it Cruella de Vil. But even though Mr. Butt just has me sitting here smiling like I'm 12. Oh. Problems, more problems. Jay-Z had 99 of them. You have like 6. The third term of a sequence is 5, and the fifth term of the sequence is 20. Which of the following statement is true? All right. The sequence is arithmetic. The first term could be 25. So third is 5, 20. So if it's arithmetic, you're looking at, well, we have to do it again. So if you're the, what was it? You were the third term. You were the fifth term. Okay. So that would be, if we're going to, say that you're A and you're B and you're F of A. Wait. Did it backwards. You would be A and you would be B. So you would be F of A and you would be F of B, right? F of B minus F of A is going to be 20 minus 5 over B minus A is going to be 5 minus 3, okay, which is going to be 15 over 2. So this could be arithmetic, in which case they want us to go back to the first term. So if this is arithmetic, going from the third term, which is 5, to the first term means I would subtract, I would take 5 and subtract 2 15s over 2s. Okay, cross you out. 5 minus 15 is negative 10, not negative 25, so you won't work. So it can't be that one. I can do the fourth term, but directly in between these two is not 7.5, so this guy ain't arithmetic. What a waste. What a waste. All right. Now, if I wanted to do this, since I have the third and fifth terms, I'm thinking 5 times what, so 5x squared has got to equal 20. Okay, so divide everything by 5, x squared equals 4, square root it, don't forget your positive or negative, and x could equal positive or negative 2. So the fourth term could be 7 if it's geometric, would be 4 times either positive or negative 2. So the fourth term would either be 10 or negative 10, not 7. You don't work. The sixth term could be 40. So what? The fifth term was 20, which means if I do 20 times positive 2, I could get 40. D is my only answer here. A bizarre question. What a bizarre question indeed. All right. Which of the following includes the input-output pairs 3, 5, and 4, 9? So 3, 5, 4, 9. It doesn't look like in any of these options getting from 5 to 9, because we go from 3 to 4, so that's consecutive. So going from 5 to 9 is most likely a plus 4. Okay? Not likely a geometric, because if it's geometric, you would times, what, 9 over 5? And none of these have 9 over 5s in them. So it's not geometric. And if it's not geometric, that means it's not exponential either, because those guys are related. So it's got to be either arithmetic or linear. So if I go from 3 to 4 and from 5 to 9, that is a slope of 4 because I went up 4. My average rate of change is 4 because I went up 4. So my slope is 4. So if I have a slope formula, or if I'm using that, if I were to do I want to do the arithmetic version of it, or do I just kind of want to do slope-intercept form? Let's just do slope-intercept form. Or better yet, let's do this. Let's do point-slope form, their version of it, and see if I get that. And if I don't get that, then that'll give me that. So slope-intercept form, f of n. If I call you x sub 1, y sub 1, you would be my m. So it's y sub 1 plus m times the quantity x minus x sub 1, which gives me y sub 1, which is 5, plus 4 times the quantity x minus 3. Which I don't see that here. Although it doesn't mean that that's not necessarily the case. I could use the point, I guess that would be the point 1, 1. If I were to use that, 1, 1 won't work. Because if I go backwards to 2, that would be 2, 1. So it can't be 1, 1. So it's got to be A. And let's just double check. Let's just double check by taking this guy, distributing. So we get 5 plus 4x minus 12, which becomes 4x, combine like terms, minus 7. Oh, they wanted to use n. Okay, n, 4n minus 7. Ugh. Didn't like that one either. I don't like any of these problems. Oh, great. And speaking of which, the next one's a trick problem. Think real life. Great. A sports team needs to buy one ball and between 1 and 5 jerseys, inclusive, for their upcoming game. The cost of the ball is $B, and the cost of every one jersey is J dollars. The output values of the following can give the possible cost of the items in dollars. Assume any taxes are included in the cost. Okay, great. Well, here's the thing. If you're buying a ball and 5 jerseys, that is in no way exponential, which means it's in no way geometric either. So it can't be exponential, and it can't be geometric. Here's the other thing. It can't be linear. And you're like, why? Well, it can't be linear because linear means I'm allowed to plug in whatever numbers I want. But if you remember what we wrote about geometric stuff earlier, that you could only use integers, arithmetic follows the same rules. So this has got to be an arithmetic sequence because you cannot plug in whatever x value that you want. This said it's like from 1 to 5. Great. But that technically means I could buy 1.5 jerseys, and that just doesn't make any sense. So the answer is C. It's got to be arithmetic. All right. Equation for percent increase, equation for percent decrease. Let's use f of x. Okay. Actually, it would be f of t. So I need to fix that. F of t, bad job by me. F of t is going to be the final value. Okay. What you're going to do is you're going to do a, which is the initial value, times 1 plus r, r being a rate as a decimal to the 10th power. So that's if I want to buy something, or if I put money into a bank and it increases by 1.2% every year, I would turn 1.2 into 0.012, and then I would put the amount of money, and then t would be time in years. This would be f of t for decrease is a times 1 minus r, and that would be like a car depreciates in value by 10% per year. What would you do there? So write an equation and answer each question. We will use just like a regular calculator off to the side. I'm not going to run to do the whole Desmos thing and waste time. This is just regular old calculations that we can use. The value of a particular baseball card increases in value 12.5% per year. The card currently has a value of $54.99. What will the value of the card be after 10 years? So f of t, you are my r, but not really. If it's 12.5%, I have to move the decimal over twice and make it 0.125. So that's my r. You are my initial value a, and you are going to be my time t. So the equation is a times 1 plus r to the t power. So this is going to be 54.99 times 1 plus 0.125 to the 10th power equals 54.99, 1.125 to the 10th. Okay? I'm going to quick run off to the side. I'm going to quick run to Desmos and find out what that number is because we don't need to go to Desmos ourselves. It's just a waste. All right, so the number that I ended up getting was 178.57018 blah 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 blah, but this is money, so it's going to be $178.57. Okay? Okay. One more problem. A bulldozer depreciates in value by 8% per year. What would the value of a 59999 bulldozer be after 20 years? All right, so we've got f of t is going to equal the initial value times 1 minus the rate to the tth power. Okay, so my rate is 8%, which means r is going to be 0.08. You're going to be a, and you're going to be t. So that's going to be 59999, 1 minus 0.08 to the t, 59999, 0.92 to the, the t was 20. So let me fix that. I don't know how I missed that. The t was 20. So how can I turn you into a 20? Nailed it. Now let me throw that into a calculator and see what happens. Okay, so the ugly number that we got there was 11321.4111, blah, 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 blah. This is money, so $11,321.41. Bulldozers just aren't the way they were 20 years ago, I'll tell you that right now. What an awful, awful, awful assignment. What an awful, awful, awful set of notes. But that's it. We're done. Run to my YouTube, please. And please type out AP Precalculus 2.2. That will take you to some of my random AP Precalculus videos that will probably give you a little bit of knowledge, a little extra oomph, a little extra bang for your buck. And you can just do a little bit more with that. Okay? So that's that. That's 2.2. We're on our way. Thanks for watching. Don't forget to like and subscribe. Don't forget to leave a comment. Thanks for watching again. I appreciate everybody. Love you. Bye.